Hello, in this video we will solve a problem based on the determinant equation of line. Since in the previous video we have already proved what is the determinant equation of line, and in this video we will solve a problem. So in this problem we have to prove that the determinant equation of line through this point and with slope m can be written as this determinant equation of line. Okay, so we have given this point and this this slope. So with these two things I have to prove that this determinant is equal to 0. Okay, since in the previous video I told you if I give you two different points, you can always draw a line passing through those 2 points. Okay, but this time we are only given 1 point and a slope, so we have to find the equation of line. How can we find an equation of line through single point and a slope? Okay, so for example, if I give you this point, you can draw many lines through it. Many lines passing through that point. So which line is correct one? Which is the best line? So you know each line has different slope. So if I give you a point and a particular slope, for example, if I give you slope 0, then you know that the line is horizontal. If I give you slope is pi by 2, that means you know, if I give you the slope is 1, that means you will draw this line, pi by 4 angle. Okay, if I give you the slope is infinity, that means you will draw a perpendicular line. So each line has unique slope. Okay, so if I give you a slope and a point, that means you can always draw a line. Since we are given point x1 y1, which is a point, and we are given a slope which is represented by m, so we can always find an equation of line through this point and this slope. Since this is algebra course, in the pre-algebra course we study how to find an equation of line through a point and a slope m. So an equation of line through this point and this slope is y minus y1 equals m times x minus x1. So this is an equation of line through a point and a slope. This what we study in pre-algebra course. So what if I shift this whole term to the left hand side of the equation? What will I get? I'll get y minus 1 y1 as it is minus m times x into m times x minus x1 equals to 0. Okay, now if I multiply this m inside here and here, what will I get? Y minus y1 as it is minus m times x is mx minus m times minus x is plus mx1. Okay, equals to 0. Now if I separate the variable terms and the constant terms, since this term is not variable because y1 is special and this is not the variable because x1 is special, this is the variable term because x is variable, this is the variable term because y is variable. So first I will write this term and this term. Okay, so first I will write y and then minus mx because this is the variable term, and then I'll write minus this term y1, and then I'll write this last term plus mx1 equals 0. Okay, so we can call that this is equation number 1. Okay, so from the given data, from the given point and a slope, I have constructed an equation of line. Okay, so generally yesterday I told you in the previous video that the equation of line is represented by ux plus vy plus w equals 0. In this case, yeah, if you write this thing first and this thing down later, I mean, if you want to write this thing in this form, you can write it. So I have shifted their place. Now this line and this general line have the same pattern. Okay, first term involving x, you can check first term involving x, the second term involves y, and the third term involves only non-variable term. So the third term is non-variable, there is no variable because they are constants. So this is the equation of line which we have constructed from the given data. Now what we have to prove? We have to prove that this determinant is equal to 0. How can we prove that this determinant is equal to 0? So what we will do, we will take this determinant and prove that this is equal to 0. Okay, so we have taken this determinant and we will prove that this is equal to 0. Okay, so how we prove that this is equal to 0? We have only one possibility. We can expand this determinant along the last row. You could expand along the first row also, you will get the same answer. You can expand it along the second row, along the third row, along the first column, second column, third column, wherever you want. Okay, but I suggest you expand the determinant along the row or the column which has most number of zeros. It will reduce the calculations. Okay, so I'll expand it along this last row. So first of all, I will write this term. For this term, I will write minus 1 to the power 3 plus 1, because this term is in the third row and the first column. Third row, and this is the third row and this is the first column. Okay, that's why 3 plus 1 times this element is 1 times the determinant by deleting this row and column, which is this one, y1 y1 1. Okay, plus again minus 1 to the power 3 plus 2, because now I have to go towards this number because I am going to expand the determinant along this last row. Since this number is in the third row and the second column, so that's why I have written minus 1 to the power 3 plus 2 times this element, which is m, I will write here m, times the determinant of the submatrix obtained by deleting this row, this column and this row, which is x, x1, 1 and 1, plus minus 1 to the power. Okay, now come to the last term, which is 0, minus 1 to the power 3 plus 3 times 0 times anything, doesn't matter because this is 0, it will kill everything. Okay, so this whole thing is 0, so I will write this is equal to 0. Okay, now solve this thing. This is just 1 because minus 1 to the power 4 is 1. So 1 times 1 is 1. 1 doesn't matter. Multiply this with this, minus this with this. Y times 1 is 1. Y times 1 is y, minus y1 times 1 is y1. Okay? Okay. This is minus because minus 1 to the power 5, which is odd number. So I will write minus, and then this m times x times 1 is x minus x1 times x1 is x1 equals 0. Okay, not equal to 0 because we don't know whether it is 0 or not. We have to prove that this is 0 because we have to prove that this determinant is 0. Okay, y minus y1 minus x mx plus mx1. Okay, rearrange write this thing first. Okay, minus mx plus y, then y minus y1, and then plus mx1. Okay, now look at equation number 1. Equation number 1 says this whole thing equals to 0. Okay, so here we got the same thing. This is the same thing as in equation number 1. So using equation number 1, this is 0. This whole thing is 0. Since this whole thing is equal to the determinant, it is equal to the determinant, so that means the determinant is 0. X, y. Okay, let me write first that this whole thing is 0 because of equation number 1. So this is equal to 0 because of equation number 1. And since this whole thing was equal to the determinant, because this step is equal to this step, and this step is equal to this step, and this step is equal to this step, and this step is equal to the determinant, that means the determinant is equal to this thing, and this thing is equal to 0 by equation number 1. Okay, what does that mean? This means the determinant is equal to 0. The determinant is equal to 0, which is already proved. This means the determinant is equal to 0.